I want to look at writing net ionic equations today, and when we do this we usually do it in three separate steps. The first step is to write a balanced chemical equation for the reaction we're looking at, and I've done that here for my first reaction, AgNO3 reacting with calcium chloride. I've written the balanced chemical equation. The next thing we want to do is we want to write what's called the full ionic equation. That is, we break down everything that's going to split up into ions in water into those ions. So you'll notice that the silver nitrate, the calcium chloride, and the sodium chloride are ions, are soluble, so they form ions, whereas the silver chloride is not. It's a solid precipitate, so we're going to leave it that way. When we write our full ionic equation, it's going to look like this, with ions for everything except for the silver chloride that is a solid. You'll notice that we had two AgNO3s, so we have two Ag plus 1s and two NO3 minus 1s. You also notice that the formula for calcium chloride is CaCl2, so we have two Cl minus 1 ions. The next thing we want to do is we're going to cross out everything that appears in the same form on both sides. So for instance, we've got two nitrates here, two nitrates here, two calciums here, two calciums here. Those are our spectator ions, and we get rid of them from our net ionic equation. When we do that, we get rid of them in our full ionic equation when we write our net ionic equation. When we do that, we get something like this. 2Ag plus 1 plus 2Cl minus 1 yields 2 AgCl solids. I usually request that people, when they have a formula like this or an equation like this where there is a common denominator that all of the components can be divided by, that they write it in the simplest form. So we would rewrite it as Ag plus 1 plus Cl minus 1 gives us AgCl. I want to look at another problem. We're going to use the same method for looking at this problem. It's a different reaction, and in this reaction we have sodium hydroxide reacting with HCl to form water and sodium chloride. We're going to start again the same way with our balanced chemical equation, and then we're going to go to write the full ionic equation where we break everything that forms ions up into those ions. So the sodium hydroxide, the HCl, and the sodium chloride form ions. The H2O is a liquid. It does not form ions. So when we write our full ionic equation, everything except for the water is split up into its ions because the water is not ionized. It has a liquid after it, not an aqueous symbol. Now finally, when we write our net ionic equation, we cross out everything that appears on both sides unchanged, all the spectator ions, and we end up with OH minus 1 plus H plus 1 gives us H2O liquid. And this is actually, anytime we react a strong acid with a strong base, this is generally the net ionic equation that we get. I want to look at one more example, and in this case we're reacting KCl and Na2SO4. We're going to take the same procedure we've been taking for all of these, starting with our balanced chemical equation. We're going to write the full ionic equation. And one thing you'll notice when we write this full ionic equation is that there are no precipitates formed. There's no solid form. Nothing turns into a liquid. Everything forms ions on the left side. Everything forms ions on the right side. Essentially everything is a spectator ion. There is no change that happens when we mix KCl and Na2SO4 together, so there would be no reaction in this case. All of our ions on this side would be crossed out with an equivalent ion on the other side.